Okay, here's another example of finding equations from given zeros. The zeros are going to be plus or minus 3 and plus or minus the square root of 5. So first of all, we're going to write our polynomial in factored form. So you can say our polynomial equation, I should say, and that's going to be, and then it's just going to be x minus 3 times x plus 3, and then x minus the square root of 5 times x plus the square root of 5. And that's going to be equal to 0. And any of these values, if we put this into this equation, we're going to get a factor that's 0, so the whole thing would be 0. Okay? Now we have to multiply it out. Now we've got 4 factors, so what I'll do is I'll multiply them out in pairs just to save myself some time. So I'll multiply, first of all, these two. And factors, so x times x is, and I use the for process, so x times x is x squared. X times 3 is plus 3x. Negative 3 times x is negative 3x. And negative 3 times positive 3 is negative 9. And then over here we've got same idea. First term, x times x is x squared. Last terms, plus the square root of 5x. Inside terms, minus the square root of 5x. And last terms, negative times a positive is a negative, and the square root of 5 times the square root of 5 is the square root of 25. And we can do some simplifying. And some of you could do this in your head here, but let's just skip this step. Call that multiplying binomials mentally, but we'll show all the steps. So x squared and 3x minus 3x is 0, so we just end up with x squared minus 9. So we kind of lucked out because we just have a binomial. And over here, positive square root of 5x minus square root of 5x is also 0, so we have minus, and the square root of 25 is 5. So we came out with a couple binomials to multiply, so this is going to be a little bit easier. So we can multiply these out. X squared times x squared is x to the 4th. And then x squared times negative 5 is negative 5 x squared. And then negative 9x squared. And then finally negative 9 times negative 5 is positive 45. And again, these are all equal to 0, so I should put a little equal 0 on all these here, because these are equations we're trying to design from the given roots. And we can simplify here finally. And we have x to the 4th, and a negative 5 and a negative 9 is negative 14 x squared plus 45, and that equals 0, and there's your equation with those roots. Now, so I can multiply everything by 2. I have 2x to the 4th minus 28x squared plus 90 equals 0. That's another equation that has the same root. So there's an infinite number we can get, but this is probably what sometimes we call this the simplest. Okay? So there's your work, and that's not too bad. So sometimes they work out a little bit easier than one might suppose.